We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, the topic for today's lecture is 4-point probe method for resistivity measurements. As we all know that this particular model is totally focused on the different types of measurement techniques. Today we will initiate with the resistivity measurement, particularly for semiconductor kind of materials. So the electrical resistivity, we will start with its definition. Electrical resistivity is one of the most sensitive indicators of changes in the nature of the chemical binding. So, with this particular phenomenon of electrical resistivity, we can easily distinguish semiconductors, conductors, and superconductors, as it is mostly related to the nature of chemical binding. In general, the electrical resistivity is inversely proportional to the carrier density and the carrier mobility. So these two are the major parameters on which the dependence of electrical resistivity is considered. A change in the nature of chemical binding primarily alters the carrier density, and the structural changes alter the carrier mobility. So this way, both the parameters affect electrical resistivity. Various models and methods have been suggested to measure the electrical resistance, but the factors affecting the suitability of various methods and precision attainable are mainly considered for the selection of methods, including the contact resistance and shape of the samples. That means whether is it in the form of a single crystal, thin film, powder pellet, or small crystalline. The method of 2 probes, which is well known, ohm meter or voltmeter emitter measurements, can be used for higher resistive samples. See, these two are the different methods, 2 probe and 4 probe. The 2 probe methods are mainly focused on the higher resistive samples, and the 4 probe methods are mainly focused for the low resistive samples. And 4 probes methods are also known as potential probe measurement methods, which is applicable for the low resistive and single crystals. This is the experimental setup for 2 probe resistivity measurements method. It is the simplest method of measuring the resistivity, and in this method the voltage drop across the sample and current through the sample capital I are measured. As you can see from the figure, the specimen of length capital L having the cross sectional area capital A is attached with the voltage source at the 2 ends, and the current flowing in the coming and closing directions are also displayed in this figure. So how the resistivity will be calculated? Using all these parameters of voltage drop capital V, cross sectional area capital A, electric current flowing and coming out from the specimen, that is capital I, will be considered, and the length of specimen, that is capital L. So the resistivity will be given as rho is equal to VA upon IL. But the drawback of this method, this is the simplest method, but as we all know, every coin has 2 sides, and thus the drawback on the other hand is we can only determine the resistivity of the samples with larger resistance. So what is the precautionary measurements to take for measurements for low resistive samples? So we have 4 probe resistivity measurements method. The fourth probe I already discussed, that is formerly known as potential probe method, is the most widely used method for resistivity measurements on the low resistive samples. Potential drop is again measured across the two probes, and additionally, in the case of two probe method, the distance between these probes, that is capital D, will be replaced by the sample length capital L. As you can see, the experimental setup is almost similar to that of two probe method, but the major change is in the consideration of the parameters which we have used in the circuits. Here the distance between this probe, as you can see, Vd is now utilized to symbolize the voltage measurement device, because the distance is now already considered, and the modification in the resistivity equation is now taken as rho is equal to Vda upon d into I. So Vd is the voltage drop, A is the cross sectional area, d is the distance between two probes, and capital I is the current flowing and coming out from the specimen. Four probe method can be also used to determine the resistance of the single crystal as well as the bulk specimen also, which is very useful to the research purpose. The 4-point probe method has proven to be a convenient tool for resistivity measurement of small size, even you can consider for order of millimeter specimen. So this is very useful. And as you can see from the figure, the surface area of specimen is also considered when the two outside current points represent the dipole, and in this case the cross sectional area will be 2 pi s. Therefore the resistivity in this case can be given by rho is equal to Vd upon I into 2 pi s. Here the distance between all the 4 points is equal, as we can confirm from this figure that all the probes are equidistant. Capital I is the current flowing through the sample, Vd is the produced voltage across two inner points, and capital S is the distance between the adjacent points. If the distance between the contact points is not equal and is given as S1, S2 and S3 respectively, suppose this condition is not satisfied and they are not equidistant, then we have to use this particular equation, the resistivity equation, because as we all know there will be no universally specimen construction, so we have to go through the options, and hence the modification in the equation has been defined. So rho is equal to V upon I into 2 pi upon 1 upon S1 plus 1 upon S3. Why these two are selected? These are the initial and ending points of the probes. Thus 1 upon S1 plus 1 upon S3 minus the inverse combination of first two probes 1 upon S1 plus S2 minus the additional combination of the last two probes, that is 1 upon S2 plus S3, where capital V is the floating potential difference. This is most important. We are not taking the general or the common potential difference between the inner probes and outer probes, but here we are considering the floating potential difference, which will be clear in the next topic, that is hot probe method, which will be detailedly explained. And capital I is the current through the outer pair of probes. So this was the 2-point method, 2-point probe method, 4-point probe method. What are their advantages, what are their disadvantages, how is the experimental setup, how we can calculate the resistivity for any kind of sample having low or high resistivity, doesn't matter. So this was the first measurement technique which we have discussed, and in our next class we will discuss about the hot probe method to distinguish the major two types of semiconductor, whether it is p type or n type. So thank you for visiting this lecture.